Hi, I'm Jerry. I want to actually confess to a terrible code crime, and that's what this talk is basically about. The crime I want to talk about was committed in 2005 when I was working on migrating some Delphi serialization code to .NET 1. And the constraint on that was to try and make it at least as fast as the Delphi code, because we had a real-time system. Basically, the electricity grid in the eastern seaboard of Australia depended on this working. Now, first, the problem with serialization is that reflection needs to be fast enough to actually get the job done. Basic reflection in .NET is pretty slow, 1,000 times slower than just accessing the property directly. Don't worry about reading all of the text. I've highlighted the most interesting bits, and I'll share the slides after the talk if I can. So basically, to get to a reasonable performance for the reflection itself, we had to get to about a factor 10 difference or so. First approach, I had to basically create code gen fast reflection myself because there were no libraries available yet off the shelf that could do that. So I took a fairly basic approach. I basically created some classes for each type that I wanted to do reflection on at runtime, code gen, which are basically big switch statements that can return the values of properties. This was close, but not quite good enough yet. It was only 20 times slower than direct access, but I needed to get to about 10 to be fast enough. The slowest component in this switch statement is the cast some object that is over there. So ideally, I want to get rid of that cast. Unfortunately, that's not valid C# code, but when you're doing code gen, you're admitting the cast explicitly yourself. And I thought, what if I just don't? Turns out that works brilliantly, and it's exactly the performance I needed to get this going. The downside is, if you throw the wrong kind of object type into this, you actually do crash the .NET VM itself. So, Sharp tool, be very careful. Now, the next thing then, having solved the reflection problem, is how to make serialization fast. Where's all of the performance problems? Well, basically, serialization is just looping over the properties on types and figuring out what to do with them. There's a lot of complex decisions involved, figuring out whether you need to skip the property, figuring out what the name of the property is that you need to serialize out, property types, and this is only a few of the decisions. There were way more in the actual code than I can show here on the slide. Quick aside, .NET has got this thing called delegates. Think of them basically as strongly typed function pointers. They're function pointers with parameter types included. So what I did in my first step is, rather than directly writing out, making those decisions and writing out the values, I created a level of abstraction. I create a processor concept, which takes an input object and writes to a binary writer output. And I created a factory method that made all of the decisions and returns the delegate that does the actual writing. So this doesn't do the actual serialization yet, but it's the first step towards it. How you then use that to get the same effect as before is you loop through all of the properties, you create the processors for them, and you invoke them. Obviously, that is not a performance win yet. This is just as slow as where we started. So the interesting thing is that you can split these two parts of the operation. You can first do all of the property processor creations and throw them all in a list. Just throw all of the delegates in a list. And then for the execution, you just loop through the list and call all of the methods. And you don't have to do that every single time. You can create another processor for the whole type as a whole, which does that looping through all of the processors and executing them, and create a cache for them against the type. So now when I use that bottom line there, however many times I want, where I want to serialize a type out to my output stream, only the first time all of the decisions get made. Everything after that is just straight method calls, one after the other. No decisions involved. Bit more abstraction now. Not all serializations are equal. Binary serialization is fairly straightforward, but when you're doing XML, you also need to worry about converting things to strings. So extra level of abstraction here. I basically introduced the getter concept, more delegates, basically get a property from this object. Then you can create factory methods for that as well, for integers, for booleans, whatever. Then you create a second delegate concept for transforms, transforming types from values from one type to another. And you do that through factory methods as well. There's a lot of factories involved and a lot of lookups involved, but none of that matters if you're doing the lookups only once, so that's not actually a performance concern. And when you then want to do XML serialization, you basically extend the string getter, create string getter factory. If the property that you want to serialize is already a string, good. Just return the same thing as before, just a straight getter on the reflection, all's done. If it's not the case, and I've hidden some of the magic here because I didn't have time to talk through all of it, but you can use some slow reflection tricks to create these delegates with parameterized types at runtime. So think of T as the actual native type of the property here. It doesn't matter, it's only temporarily relevant while we get the getter, and then a transform from that actual type to string. And then I mash them together, converter around the getter, and hey, I've got a string getter. So the good thing is that then for XML serialization, everything looks like a string. It doesn't matter, everything is a string. Interesting side effect when you start thinking of serialization as a composition of getters, transforms, and processors is why should we just use the hard-coded ones that I provided myself? So at that point, I also introduced an interface on the serialization concept to inject transforms, for example. So you can set them globally by type, by property, whatever. And the cool thing is it doesn't cost you anything. These decisions get made once, and everything is already a transform invocation anyway, so who cares that you're adding this flexibility in it? The only cost that you pay is for the actual logic that you want to execute to do the transform in whatever form you want, which is the cost that you can't avoid anyway. Now, there's obviously a few more complex properties that I also want to talk about. If you have a property that's either an object or a collection, you can do the same kind of thing. So we create property processors for those object properties, but the factories work a little bit differently. Starting with the object processor, if you have an object property like nested, or could be anything there in the example, basically fairly straightforward. You return a processor again, and what the processor does, it gets the object property, and then it creates a type processor for the type of the item that you found, and you invoke that. Remember that those are all cached, so it doesn't matter, it happens only once. After that, it's just method invocations all the way down. But what's even more cool is the sealed concept that .NET has. That's the equivalent of making a type uninheritable. At that point, what I know about the nested property there is it's always going to be a SOM object. It can't be anything else. So I can exploit that in my serialization. I can do the type processor lookup once and return a delegate that just invokes it on whatever is in the property because I know it will always be a SOM object. So now I'm not even doing the type lookup anymore. Even more interestingly, you can do the same for the collections. If I have a collection of something that is of a fixed type, then I can get that type processor outside of the loop as well and just run it over all of the elements in the collection with wild abandon. And at that point, I basically don't have any decisions left once I'm doing my serialization. Every decision gets made exactly once for every property where necessary, and the rest of the execution is just as fast as it can be. Now, I did lie a little bit at the start. This isn't quite the same as the Delphi serialization that we started from, for obvious reasons. Delphi has runtime reflection, value properties, object properties, collection properties. But for .NET, what we actually implemented, what I built instead, was on top of that ability to do property skipping, property renames, because we wanted to change the object model between this transition as well, doing type transformations, as you saw before, these sealed type optimizations, and a whole bunch of other niggly things besides. Despite all of that, the .NET serialization was actually twice as fast as the Delphi one that we started with, which had hand-tuned assembly in it, so I felt pretty good about that. The principle, I think, is actually more broadly applicable than just to serialization. The idea here is you're basically looking for complex conditionals or really wild trees of conditionals in your logic, in your loops. And you want to look for conditionals that are dependent on inputs that are fairly stable over the execution. Well, they have to be completely stable over the execution, but that can be for the duration of program execution, maybe a TCP session, or a significantly lengthy algorithm. And what you then do is you split those decisions into a create processor kind of thing, and the rest is an execute processor kind of thing. And then you cache all of those create processor steps. And then you do all of the decisions exactly once. Now, final thought, why didn't we do more code gen? Because we already had code gen for the reflection to be fast enough. Turns out that code gen is very hard to get right. You can very easily break your system in very non-trivial and hard to debug ways. Besides which, we had already beaten Delphi performance, so I wasn't really too incentivized to look further. But on top of that, at the time that all of this was happening, this serialization was outperforming disk I/O and network I/O, so there was literally no way to get more data out there anyway. That's pretty much 10 minutes. Wonderful. If you want to know anything more, just find me here or hit me up on that handle.